GSM, or Global System for Mobile Communications, is defined as a set of mobile communications standards and protocols governing second-generation or 2G networks, first developed and deployed in Europe. GSM is a digital cellular communication standard that is universally accepted. The European Telecommunication Standards Institute created the GSM standard to define the procedures for second-generation digital mobile networks that are used by devices such as mobile phones. It is a wide-area communications technology program that utilizes digital radio channeling to bring forth audio, information, and multimedia communication systems. GSM is a mobile network and not a computer network. Opens a new window. This implies that devices interact with it by looking for nearby cells. GSM, including other technological advances, has influenced the evolution of mobile wireless telecommunication services. A GSM system manages communication between mobile stations, base stations, and switching systems. Every GSM radio channel is 200 kHz wide and is additionally divided into frames of 8 time slots. The Global System for Mobile Communication, GSM, was first known as Group Special Mobile, which is the reason for the acronym. The GSM system comprises mobile stations, base stations, and intertwining switching systems. The GSM program enables 8 to 16 audio users to share every radio channel, and every radio transmission location may have multiple radio channels. Because of its simplicity, affordability, and accessibility, GSM is presently the most commonly used network technology in the Internet of Things, IoT, opens a new window applications. However, this is likely to change in the coming years. Various programs have been designed without the advantage of standardized provisions all through the transformation of mobile telecommunication services. This significantly created many issues tied directly to consistency as digital radio technology advanced. The Global System for Mobile Communication is designed to address these issues. GSM accounts for about 70% of the world's digital cellular services. GSM automates and encodes the information before transmitting it via a channel, including 3 distinct streams of user information inside each time slot. For the vast majority of the world, it is also the leading 2G digital cell phone standard. It governs how cell phones interact with the land-based tower system. In Europe, GSM operates in the 900 MHz and 1.8 GHz bands, while in the United States, it functions in the 1.9 GHz PCS band. GSM describes the overall mobile network, not just the time division multiple access air interface, as it is centered on a circuit-switched structure that splits every 200 kHz channel into 8 25 kHz time frames. It is a rapidly expanding transmission technique, with over 250 million GSM users by the early 2000s. The 1 billionth GSM consumer was linked by mid-2004. The Global System for Mobile Communications, GSM, is a standard developed by the European Telecommunication Standards Institute, ETSI, to describe the protocols for second-generation, 2G, digital cellular networks used by mobile devices such as mobile phones and tablets. GSM is also a trademark owned by the GSM Association. GSM may also refer to the full-rate voice codec. It was first implemented in Finland in December 1991. By the mid-2010s, it became a global standard for mobile communications, achieving over 90% market share, and operating in over 193 countries and territories. 2G networks developed as a replacement for first-generation, 1G, analog cellular networks. The GSM standard originally described a digital, circuit-switched network optimized for full duplex voice telephony. This expanded over time to include data communications, first by circuit-switched transport, then by packet data transport via General Packet Radio Service, GPRS, and enhanced data rates for GSM evolution, ETSI. Subsequently, the 3GPP developed third-generation, 3G, UMTS standards, followed by the fourth-generation, 4G, LTE advanced and the fifth-generation 5G standards, which do not form part of the ETSI GSM standard. Beginning in the late 2010s, various carriers worldwide started to shut down their GSM networks. Nevertheless, as a result of the network's widespread use, the acronym GSM is still used as a generic term for the plethora of G mobile phone technologies evolved from it. In 1983, work began to develop a European standard for digital cellular voice telecommunications when the European Conference of Postal and Telecommunications Administrations, CEPT, set up the Group Special Mobile, GSM, committee and later provided a permanent technical support group based in Paris. 5 years later, in 1987, 15 representatives from 13 European countries signed a Memorandum of Understanding in Copenhagen to develop and deploy a common cellular telephone system across Europe, and EU rules were passed to make GSM a mandatory standard. The decision to develop a continental standard eventually resulted in a unified, open, standard-based network which was larger than that in the United States. In February 1987, Europe produced the first agreed GSM technical specification. Mobile Teleceratout ministers from the 4 big EU countries cemented their political support for GSM with the Bonn Declaration on Global Information Networks in May, and the GSM MAU was tabled for signature in September. The MAU drew in mobile operators from across Europe to pledge to invest in new GSM networks to an ambitious common date. In this short 38-week period, the whole of Europe, countries and industries, had been brought behind GSM in a rare unity and speed, guided by 4 public officials: Armin Silberhorn, Germany; Stephen Temple, UK; Philippe Dupuis, France; and Renzo Fili, Italy. In 1989, the Group Special Mobile Committee was transferred from CEPT to the European Telecommunication Standards Institute, ETSI. The IEEE/RSE awarded to Thomas Haug and Philippe Dupuis the 2018 James Clerk Maxwell Medal for their leadership in the development of the first international mobile communications standard, with subsequent evolution into worldwide smartphone data communication. The GSM, 2G, has evolved into 3G, 4G, and 5G. In parallel, France and Germany signed a joint development agreement in 1984 and were joined by Italy and the UK in 1986. In 1986, the MTS and European Commission proposed reserving the 900 MHz spectrum band for GSM. It was long believed that the former Finnish Prime Minister Harri Holkeri made the world's first GSM call on July 1, 1991, MTS calling Kaarina Suonio, deputy mayor of the city of Tampere, using a network built by Nokia and Siemens and operated by Radio Linja. In 2021, a former Nokia engineer, Pekka Lonka, revealed to Helsingin Sanomat making a test call just a couple of hours earlier. World's first GSM call was actually made by me. I called Marjo Jousainen, in Salo, Lonka informed. The following year saw the sending of the first short messaging service, SMS or text message, MS, and Vodafone UK and Telecom Finland signed the first international roaming agreement. Work began in 1991 to expand the GSM standard to the 1800 MHz frequency band, and the first 1800 MHz network became operational in the UK by 1993, MA called and DCS 1800. Also that year, Telstra became the first network operator to deploy a GSM network outside Europe, and the first practical handheld GSM mobile phone became available. In 1995, fax, data, and SMS messaging services were launched commercially. The first 1900 MHz GSM network became operational in the United States, and GSM subscribers worldwide exceeded 10 million. In the same year, the GSM Association formed. Prepaid GSM SIM cards were launched in 1996, and worldwide GSM subscribers passed 100 million in 1998. In 2000, the first commercial MTS General Packet Radio Service, GPRS, services were launched, and the first GPRS-compatible handsets became available for sale. In 2001, the first MTS and UMTS, WCDMA, network was launched, a 3G technology that is not part of GSM. Worldwide GSM subscribers exceeded 500 million. In 2002, the first multimedia messaging service, MMS, was introduced and the first GSM network in the 800 MHz frequency band became operational. Enhanced data rates for GSM evolution, EDGE, services first became operational in a network in 2003, and the number of worldwide GSM subscribers exceeded 1 billion in 2004. By 2005, MTS GSM networks accounted for more than 75% of the worldwide cellular network market, serving 1.5 billion subscribers. In 2005, the first SPA-capable network also became operational. The first SUPA network launched in 2007. High-speed packet access, HSPA, and its uplink and downlink versions are 3G technologies, not part of GSM. Worldwide GSM subscribers exceeded 3 billion in 2008. The GSM Association estimated in 2011 that technologies defined in the GSM standard served 80% of the mobile market, encompassing more than 5 billion people across more than 212 countries and territories, making GSM the most ubiquitous of the many standards for cellular networks. GSM is a second-generation, 2G, standard employing time division multiple access, TDMA, spectrum sharing, issued by the European Telecommunication Standards Institute, ETSI. The GSM standard does not include the 3G Universal Mobile Telecommunications System, UMTS, Code Division Multiple Access, CDMA, technology, nor the 4G LTE Orthogonal Frequency Division Multiple Access, OFTMA, technology standards issued by the 3GPP. GSM, for the first time, set a common standard for Europe for wireless networks. It was also adopted by many countries outside Europe. This allowed subscribers to use other GSM networks that have roaming agreements with each other. The common standard reduced research and development costs, since hardware and software could be sold with only minor adaptations for the local market. Telstra in Australia shut down its 2G GSM network on December 1, 2016, the first mobile network operator to decommission a GSM network. The second mobile provider to shut down its GSM network, on January 1, 2017, was AT&T Mobility from the United States. Optus in Australia completed the shutdown of its 2G GSM network on August 1, 2017, part of the Optus GSM network covering Western Australia and the Northern Territory had earlier in the year been shut down in April 2017. Singapore shut down 2G services entirely in April 2017. The network is structured into several discrete sections. Base station subsystem, the base stations and their controllers. Network and switching subsystem, the part of the network most similar to a fixed network, sometimes just called the core network. GPRS core network, the optional part which allows packet-based internet connections. Operations support system, OSS, network maintenance. GSM utilizes a cellular network, meaning that cell phones connect to it by searching for cells in the immediate vicinity. There are 5 different cell sizes in a GSM network: macro, micro, pico, femto, and umbrella cells. The coverage area of each cell varies according to the implementation environment. Macro cells can be regarded as cells where the base station antenna is installed on a mast or a building above average rooftop level. Micro cells are cells whose antenna height is under average rooftop level, they are typically deployed in urban areas. Picocells are small cells whose coverage diameter is a few dozen meters, they are mainly used indoors. Femtocells are cells designed for use in residential or small business environments and connect to a telecommunications service provider's network via a broadband internet connection. Umbrella cells are used to cover shadowed regions of smaller cells and to fill in gaps in coverage between those cells. Cell horizontal radius varies, depending on antenna height, antenna gain, and propagation conditions, from a couple of 100 meters to several tens of kilometers. The longest distance the GSM specification supports in practical use is 35 kilometers, 22 miles. There are also several implementations of the concept of an extended cell, where the cell radius could be double or even more, depending on the antenna system, the type of terrain, and the timing advance. GSM supports indoor coverage, achievable by using an indoor picocell base station, or an indoor repeater with distributed indoor antennas fed through power splitters, to deliver the radio signals from an antenna outdoors to the separate indoor distributed antenna system. Picocells are typically deployed when significant call capacity is needed indoors, as in shopping centers or airports. However, this is not a prerequisite, since indoor coverage is also provided by in-building penetration of radio signals from any nearby cell. GSM networks operate in a number of different carrier frequency ranges, separated into GSM frequency ranges for 2G and UMTS frequency bands for 3G, with most 2G GSM networks operating in the 900 MHz or 1800 MHz bands. Where these bands were already allocated, the 850 MHz and 1900 MHz bands were used instead, for example in Canada and the United States. In rare cases the 400 and 450 MHz frequency bands are assigned in some countries because they were previously used for first-generation systems. For comparison, most 3G networks in Europe operate in the 2100 MHz frequency band. For more information on worldwide GSM frequency usage, see GSM frequency bands. Regardless of the frequency selected by an operator, it is divided into time slots for individual phones. This allows 8 full-rate or 16 half-rate speech channels per radio frequency. These 8 radio time slots, or burst periods, are grouped into a TDMA frame. Half-rate channels use alternate frames in the same time slot. The channel data rate for all 8 channels is 270.833 kbit/s, and the frame duration is 4.615 milliseconds. The transmission power in the handset is limited to a maximum of 2 watts in GSM 850/900 and 1 watt in GSM 1800/1900. GSM has used a variety of voice codecs to squeeze 3.1 kHz audio into between 7 and 13 kbit/s. Originally, 2 codecs, named after the types of data channel they were allocated, were used, called half-rate, 6.5 kbit/s, and full-rate, 13 kbit/s. These used a system based on linear predictive coding, LPC. In addition to being efficient with bit rates, these codecs also made it easier to identify more important parts of the audio, allowing the air interface layer to prioritize and better protect these parts of the signal. GSM was further enhanced in 1997 with the enhanced full-rate, EFR, codec, a 12.2 kbit/s codec that uses a full-rate channel. Finally, with the development of UMTS, EFR was refactored into a variable rate codec called AMR narrowband, which is high quality and robust against interference when used on full-rate channels, or less robust but still relatively high quality when used in good radio conditions on half-rate channel. One of the key features of GSM is the subscriber identity module, commonly known as a SIM card. The SIM is a detachable smart card containing a user's subscription information and phone book. This allows users to retain their information after switching handsets. Alternatively, users can change networks or network identities without switching handsets, simply by changing the SIM. Sometimes mobile network operators restrict handsets that they sell for exclusive use in their own network. This is called SIM locking and is implemented by a software feature of the phone. A subscriber may usually contact the provider to remove the lock for a fee, utilize private services to remove the lock, or use software and websites to unlock the handset themselves. It is possible to hack past a phone locked by a network operator. In some countries and regions, e.g. Brazil and Germany, all phones are sold unlocked due to the abundance of dual SIM handsets and operators. GSM was intended to be a secure wireless system. It has considered the user authentication using a pre-shared key and challenge, response, and over-the-air encryption. However, GSM is vulnerable to different types of attack, each of them aimed at a different part of the network. The development of UMTS introduced an optional Universal Subscriber Identity Module, USIM, that uses a longer authentication key to give greater security, as well as mutually authenticating the network and the user, whereas GSM only authenticates the user to the network, and not vice versa. The security model therefore offers confidentiality and authentication, but limited authorization capabilities, and no non-repudiation. GSM uses several cryptographic algorithms for security. The A5/1, A5/2, and A5/3 stream ciphers are used for ensuring over-the-air voice privacy. A5/1 was developed first and is a stronger algorithm used within Europe and the United States. A5/2 is weaker and used in other countries. Serious weaknesses have been found in both algorithms. It is possible to break A5/2 in real time with a ciphertext-only attack, and in January 2007, the Hackers' Choice started the A5/1 cracking project with plans to use FPGAs that allow A5/1 to be broken with a rainbow table attack. The system supports multiple algorithms so operators may replace that cipher with a stronger one. Since 2000, different efforts have been made in order to crack the A5 encryption algorithms. Both A5/1 and A5/2 algorithms have been broken, and their cryptanalysis has been revealed in the literature. As an example, Karsten Knoll developed a number of rainbow tables, static values which reduce the time needed to carry out an attack, and have found new sources for known plaintext attacks. He said that it is possible to build a full GSM interceptor from open source components, but that they had not done so because of legal concerns. Knoll claimed that he was able to intercept voice and text conversations by impersonating another user to listen to voicemail, make calls, or send text messages using a 7-year-old Motorola cell phone and decryption software available for free online. GSM uses General Packet Radio Service, GPRS, for data transmissions like browsing the web. The most commonly deployed GPRS ciphers were publicly broken in 2011. The researchers revealed flaws in the commonly used GSM-1 and GSM-2, standing for GPRS encryption algorithms 1 and 2, ciphers, and published the open-source GPRS decode software for sniffing GPRS networks. They also noted that some carriers do not encrypt the data, i.e., using GSM-0, in order to detect the use of traffic or protocols they do not like, example Skype, leaving customers unprotected. GSM-3 seems to remain relatively hard to break and is said to be in use on some more modern networks. If used with USIM to prevent connections to fake base stations and downgrade attacks, users will be protected in the medium term, though migration to 128-bit GSM-4 is still recommended. The first public cryptanalysis of GSM-1 and GSM-2, also written GSM-1 and GSM-2, was done in 2021. It concluded that although using a 64-bit key, the GSM-1 algorithm actually provides only 40 bits of security, due to a relationship between two parts of the algorithm. The researchers found that this relationship was very unlikely to have happened if it wasn't intentional. This may have been done in order to satisfy European controls on export of cryptographic programs. The GSM systems and services are described in a set of standards governed by ETSI, where a full list is maintained. Several open-source software projects exist that provide certain GSM features. GSM daemon by OpenMoko. OpenBTS develops a base transceiver station. The GSM software project aims to build a GSM analyzer for less than $1,000. Osmocom BB developers intend to replace the proprietary baseband GSM stack with a free software implementation. Yate BTS develops a base transceiver station. Patents remain a problem for any open-source GSM implementation, because it is not possible for GNU or any other free software distributor to guarantee immunity from all lawsuits by the patent holders against the users. Furthermore, new features are being added to the standard all the time, which means they have patent protection for a number of years. The original GSM implementations from 1991 may now be entirely free of patent encumbrances. However, patent freedom is not certain due to the United States' first-to-invent system that was in place until 2012. The first-to-invent system, coupled with patent term adjustment, can extend the life of a U.S. patent far beyond 20 years from its priority date. It is unclear at this time whether OpenBTS will be able to implement features of that initial specification without limit. As patents subsequently expire, however, those features can be added into the open source version. As of 2011, there have been no lawsuits against users of OpenBTS over GSM use. GSM stands for Global System for Mobile Communication. GSM is an open and digital cellular technology used for mobile communication. It uses 4 different frequency bands of 850 MHz, 900 MHz, 1800 MHz, and 1900 MHz. It uses the combination of FDMA and TDMA. This article includes all the concepts of GSM architecture and how it works. GSM is having 4 different sizes of cells are used in GSM. 1. Macro, in this size of cell, base station antenna is installed. 2. Micro, in this size of cell, antenna height is less than the average roof level. 3. Pico, small cells diameter of few meters. 4. Umbrella, it covers the shadowed, fill the gaps between cells, regions. Features of GSM are: 1. Supports international roaming. 2. Clear voice clarity. 3. Ability to support multiple handheld devices. 4. Spectral/frequency efficiency. 5. Low-powered handheld devices. 6. Ease of accessing network. 7. International ISDN compatibility. 8. Low service cost. 9. New features and services. GSM is nothing but a larger system which is divided into further 3 subsystems. 1. BSS, BSS stands for Base Station Subsystem. BSS handles traffic and signaling between a mobile phone and the network switching subsystem. BSS having 2 components, BTS and BSC. 2. NSS, NSS stands for Network and Switching Subsystem. NSS is the core network of GSM that carried out call and mobility management functions for mobile phone present in network. NSS have different components like VLR, HLR, and EIR. 3. OSS, OSS stands for Operating Subsystem. OSS is a functional entity which the network operator monitor and control the system. OMC is the part of OSS. Purpose of OSS is to offer the customer cost-effective support for all GSM-related maintenance services. Services of GSM. 1. Bearer services/data services. GSM specifies different mechanism for data transmission, the original GSM allowing for data rates of up to 9600 bits/s. Bearer services permit transparent or non-transparent data transmission. Transparent bearer services. Transparent bearer services only use the physical layer to transmit data. Data transmission has a constant delay at throughput if no transmission error occurs. Non-transparent bearer services. Non-transparent bearer services use protocols of layer 2 and 323 to implement error correction and flow control, data link layer and network layer. 2. Teleservices. Teleservices are nothing but we use now as at also. Video calls. Video text and face emoji. Short text message, SMS. 3. Supplementary services. Supplementary services, it means advanced services. Conference calls. Call waiting. Call forwarding. GSM security. GSM offers several security using confidential information stored in the AUC and in the individual SIM. The SIM stores personal secret data and is protected with a PIN against unauthorized use. Advantages. Compatibility. GSM is widely used around the world, so it is compatible with many different networks and devices. Security. GSM offers enhanced security features such as authentication, encryption, and confidentiality, which helps to protect the user's privacy and data. Efficient use of bandwidth. GSM uses a time division multiplexing (TDM) technique which enables many users to share the same frequency channel at different times, making it an efficient use of the available bandwidth. Roaming. GSM allows users to roam internationally and use their mobile phones in other countries that use the same GSM standard. Wide range of features. GSM supports a wide range of features, including call forwarding, call waiting, voicemail, conference calling, and more. Disadvantages. Limited coverage. GSM networks may have limited coverage in some remote areas, which can make it difficult for users to make calls or access the internet. Network congestion. GSM networks may become congested during peak hours, which can lead to dropped calls or poor call quality. Security vulnerabilities. Although GSM offers enhanced security features, it is still vulnerable to certain types of attacks, such as eavesdropping and spoofing. Data transfer speed. GSM networks offer relatively slow data transfer speeds compared to newer technologies such as 3G and 4G. Limited capacity. GSM networks have a limited capacity for handling large volumes of data, which can be a disadvantage for users who require high-speed internet access or other data-intensive applications. Hence, this is the complete architecture and functionalities of GSM components. We live in the 5G generation, yet GSM remains a standard technology for mobile phones, and IoT device management opens a new window environments. This is because it is a building block for wireless connectivity, particularly in remote regions. GSM also functions as a redundancy method, helping systems stay connected even if the primary networks are offline. Enterprises must understand and accommodate GSM technology to build a sustainable IoT environment.